Everyone, welcome back to the PONEX session. We will continue with the presentations. First, we have two virtual talks to begin with, one in-person talk and one some recording discussion time. So for the first talk, I'm inviting Benji from ECCC to present the preliminary results from EarthCARE about Meteorological. Japan, over to you.
Okay, thank you very much. Hello, everyone. Good afternoon. Today I will talk about, give an overview presentation for the ECCC campaign, which stands for EarthCARE Commissioning Carval campaign in Ottawa. Firstly, I want to thank the contribution from all the co-authors listed here from ECCC, NRC, McGill, UQAM, U of T, as well as the support from European Space Agency and EarthCARE Level 2 algorithm development team. Next slide, please. Yeah, EarthCARE was launched in May 2024 with four main instruments on board the satellite, including Athlete LiDAR, CPR radar, MSI multispectral imager, and BBR broadband radiometer. The goal is to enhance our comprehension of aerosol cloud radiation dynamics at a global level. After the launch, EarthCARE entered its commissioning phase from June to December 2024, during which there were intensive carval activities. This is in this context that ECCC campaign was conducted. ECCC was an airborne and surface campaign with Ottawa as a home base. In order to carve out EarthCARE's Level 1 and Level 2 product, for which I will show some examples during this presentation. Next slide, please. So here is the list of instruments. We used NRC's Convair 580 research aircraft, on which there are triple frequency radar, elastic cloud LiDAR, and HISRAM, Aerosol spectrometer, and a suite of cloud microphysical instruments. On the surface, ECCC deployed halo LiDAR, dial water vapor LiDAR, micro-rain radar, and microwave radiometer, and some other instruments. At the same time, McGill University also deployed a broadband net radiometer and the ARRI instrument for observing infrared radiation at the same location. We also collaborate with the Climate Sentinel surface network operated by McGill and UQAM, mostly for two stations in the Montreal region. Next slide, please. In total, we conduct 7 ECCC flights. Three of them observed liquid cloud, and 4 of them observed ISM mixed phase clouds. As you can see, those sampling region are highlighted by those rectangles on the right side on the map. So today's presentation, I will mostly focus on Flight 5 about the validation of Level 1 radar and LiDAR product, and then Level 2 cloud retrieval validation. I will also briefly talk about Flight 4 for the scene construction validation, and eventually some surface validation. Next slide, please. Here is for ECCC Flight 5 on November 22nd. On the left side is MSI visible channel, and on the right side is the thermal channel. So for this day, there are a lot of clouds, and the orange line shown here is the underflight path, coordinated underflight path of Convair flying along EarthCARE's orbit. So the later part results I will show will be coming from this underflight path to compare with EarthCARE's observation. So next slide, please. So here, courtesy, so I will this will be the Level 1 radar validation, courtesy to Paloma Borg from NRC. The first panel is from the EarthCARE's CPR reflectivity after applying a 5 dBz correction due to a general underestimation of the reflectivity. And the lower panel is showing Convair's reflectivity. So comparing these two images, we can see that they are having very similar features. And on the right side, there are this is a scatter plot with more than 10,000 points to compare, with a very high coefficient of determination higher than 0.96. So generally speaking, agreement in terms of radar reflectivity is very good. Next slide, please. So here is the level 1 LiDAR validation courtesy to Q1 Ranchpa from NRC. In panel B is the athlete total backscatter, and panel C is the Convenors LiDAR's total backscatter. You can see they observe, again, very similar features, and you can also see the liquid layer with high supercooled layer with high backscatters. However, due to EarthCARE and then Convenor have different type of LiDAR, so the comparison can be quite complicated. So the validation effort is continued in order to ensure that the results will be compared reasonably. Next slide, please. So here, level 2 ice cloud retrieval validation. The panel A is showing the synergy product from EarthCARE using both radar, LiDAR, and MSI observation at the same time. And then panel B is the composite retrieval of ice water content using single instrument retrievals and then combine them together. And panel C is the retrieval from the synergy and composite product will then compared with the in situ observation showing in panel C. The black line is the in situ observation from Convenors in situ probes. So generally, you can see the agreement is quite good. And this is also reflected in the scattered plot on the right side, especially for synergy product. The agreement is quite good. There's almost no bias. And for the composite product in panel F, the agreement is good, but there is a slight positive bias. Generally speaking, for the ice water content retrieval, the performance is quite good. So next slide. However, the challenge is to retrieve liquid and mixed phase clouds. So in this image, panel B, you can see in those two highlighted area, the Convenors LiDAR, Convenors LiDAR signal is significantly attenuated due to the presence of liquid just above the aircraft level. This is also reflected by the in situ observation in panel E. So in those shaded area, you will see there are in situ observations in black lines. However, EarthCARE didn't retrieve any liquid water in those two highlighted area. But if you look at the panel D, these are the cross-section of liquid water content retrieved by synergy product. And you will see in those two shaded area, there are liquid layer just above and below the aircraft altitude, which is in red line, indicating that the synergy retrieval get quite good, reasonable liquid water content, especially when they are close to the cloud top, for which LiDAR can give additional information to differentiate cloud phase. More challenging part is to retrieve mixed phase cloud deeper in clouds. So this is currently ongoing efforts for the EarthCARE retrieval. Next slide, please. So now I will switch to slide 4 for for the scene construction algorithm validation. So the purpose of the scene construction is to build 3D cloud and aerosol scenes. If you look at the image on the upper right side, so the method is that for a given off-track off-nadir pixel IG, we will search most similar a pixel on the nadir track in the center in terms of radiance. Once we find those best match pixel on the nadir, we will use the active sensor retrieved cloud and aerosol profile to transplant them into the off-native region, the pixels. By repeating this process, we can produce a 3D cloud and aerosol scene and then used for radiative transfer calculation. The middle panel B is a reconstructed image using the nadir pixel, comparing to the original MSI image on the left side, panel A. So you will see both images looks quite similar, except that there are some construction errors pointed by the red arrow. These, however, they are far away from the nadir track and usually not used for radiative transfer calculation. And so to evaluate impact of scene construction, I shows two line plots on the right side. The blue line shows the bias and room mean square error, and plotted against the distance with regard to the nadir track. What we expect is that when we get a wave moving away from the nadir track, the construction quality will decrease accordingly. However, in this case, the bias and the room mean square stay quite stable from 0 to almost 11 kilometers, indicating that the scene construction doesn't really introduce a lot of errors by doing this. So it's a good indication that the quality of the scene construction. Next slide, please. Then I will switch to the surface validation. My colleague Zen Mariani also performed some validation to check for the temperature and the humidity. Although EarthCARE didn't really directly retrieve temperature and humidity, but it will use those information for the radiative transfer calculation. Those information are coming directly from ECMWF models. So for the 6 EarthCARE overpass shown here, Zen find there are some differences, although they are relatively small. However, their radiative impact in the closure assessment, we will further look into this. On the right side is a cloud-based detection example. The background color is from the aerosol backscatter. The blue color shows the boundary of clouds. And then the black diamond sign is EarthCARE derived cloud-based height, which is quite close to what is observed by the LiDAR, indicating that the cloud-based estimation from EarthCARE is relatively good. So next slide, please. And so finally, Lei Liu from McGill University also performed surface spectral radiative closure assessment, which is very important for verify the general performances of EarthCARE satellite. Here he used the ARRI observed spectral radiances, which is showing in the red line in this spectrum image. And then he also performed line-by-line radiative transfer calculation using the EarthCARE retrieved clouds, different products, and to produce those spectral radiances showing in this image with the line of other colors than other colored lines. For example, using composite version 1 product, we will see there are quite large differences between this blue line and red line. However, upgrading to a more improved composite version 2 and synergy cloud retrievals, then the difference significantly reduced, indicating a better cloud retrieval qualities. However, there's still some, even with those improved radiances, there are still some differences. So there's warrant further investigation in order to understand why we have those differences, including that Zen also previously showed those images with the temperature and humidity bias. So next slide, please. So finally, to conclude, ECCC campaign, we can conduct the airborne and surface observation, and the preliminary validation analysis also provide useful, valuable information to support EarthCARE's CalVav activities efforts. And in the future, we will continue working on enhancing the data quality We'll also work on the Doppler velocity validation and the level 2 radar validation. We're also looking at ice particle size distribution and its impact on cloud retrieval. Broadband radiative closure assessment at surface. We're also looking at that. And also some work on the validation comparisons using NWP model simulation that related to Melissa Cholet's work. She will, for example, she will talk about in the next presentation. Also, the data version conversion, so that for the data delivery. And finally, all the accumulated experience from ECALOT will be very useful for PONEX campaign, as there will be an EarthCARE Carve-out component for PONEX. And also having Ali and then Field 2 instrument will bring in additional information to help for the calibration validation efforts for EarthCARE. Yeah. Thank you very much.
Thanks very much, Zipeng. Are there any questions or online?
Thank you very much, Zipeng. The question that I have for the comparison of ground-based measurement like LiDAR or ARIES with the satellite, is there a specific radius that you consider, or how you select if you should compare the scale?
Sorry, Kiwan. My sound I hear is extremely faint. I can hardly understand what you said.
I just said that. Is there a specific radius that you consider when you compare the ground-based measurement, for example, LiDAR, with the EarthCARE orbit?
Can you repeat again?
Yeah,
Sorry.
I'll try to repeat it here and see if it works better without tech. Kevin is asking if you consider a specific radius within which you can compare EarthCARE measurements with ground-based measurements.
Sorry, I cannot really understand the question. Yeah, there's a lot of noise in the sound. Kiwan, maybe we can talk about this offline.
Sounds good. Thank you, Japan.
Yeah.
If there are no other questions. Oh, Zipeng, there we go. Kaley just wrote the question in the chat. If you could respond to that.
Okay, I will respond.
You can say it too. Okay. So we'll move on. Thanks very much, Zipeng.
And our next presenter is Melissa. Melissa, can you try speaking and sharing your screen?
Right, hello, can you hear me?
Yes, that's excellent.
Oh, okay, great, because my sound is also really bad, but anyway, maybe I will turn off my camera once everyone sees me. That would be better. Can you share the presentation for me, please?
Sounds good, will do.
Okay, thank you. Great, I can see it. So I will start. Let me know if the sound is bad or if the connection is lost somehow. All right. Hello, everyone. My name is Melissa. I'm a research scientist at ECCC in the same group as Zen and HAWC and Chopin. I will discuss the plan for the high resolution modeling activities that is planned for the PONEX campaign. So next slide, please. So this is a slide that Zen mentioned this morning, but I think one of the overall goal of this campaign is to improve the weather forecast in the polar region, and this through a better understanding of key physical processes, and eventually actually improving the representation of those processes in models. So, so as Zen mentioned in his talk, the first objective is sub-orbital calibration and validation. And the second one is to acquire some new knowledge about the following science components, which I will get into a little bit more detail later. But Alexi also gave a really good overview of this. So next slide, please. Today, actually, I'm just going to describe the plan for the high-resolution modeling activities for PONEX, as I said, and this will be with the GEM model. So I'm not going to cover anything about what people may have been planned for CAN-SEM and GEMMAC. So yeah, next slide, thank you. So first, the ECCC and the WP high resolution system in that region are two. The first one is the HRDPS, so the high resolution deterministic prediction system. And the second one is the Canadian Arctic prediction system, the CAPS. The domains are shown on the right. So basically the difference between the two systems is first the orbital grid spacing, although that may change for the next innovation cycle that will happen next year. I'm not sure about it. But and the other thing that is different is that CAPS is coupled with the ocean, whereas the HRDPS is not. What it is sure is that, for example, this is one of the challenges that we have in the HRDPS, so in the north region of Canada. There is a warm bias, which seems to be increasing over time during the forecast. And this is for the error for 40 cases during winter 2022. It seems also to have a positive precipitation bias that may or may not, we're not sure yet, but be associated with the low-level clouds. So those are our challenges that we will eventually try to improve with PONEX, with what will be done during PONEX. So next slide, please. So actually, the plan is to go to higher resolution, and for two reasons. Well, for many reasons, but main reason is to get to get access to the system more easily, to change things if we need it on time on the site directly and so on. So the grid is in blue, so it's going to be smaller and within the CAP system. So it will actually be driven by the CAPS system. And it will cover the area of PONEX, which is shown by the circle in the figure. The objectives are two. The first one is to provide guidance for flights planning, so in support of any other forecast systems that are already planned to be used. And for that, we'll use actually real-time forecast, and the output will be adapted to the needs, and that will be discussed later if we have the time. That would be great. And then the other objective is to study scientific challenge in during polar night, and for that we could use real-time or in-cast simulations that depend on what we want to study, and of course we're going to compare with the PONEX data. So this is the configuration. I'm not going to go into the detail of all this, but this is really technical. But it will essentially just be at higher resolution than the CAPS. So next slide, please. All right. So first, scientific objective. Alexi mentioned it a little bit earlier for the cloud and microphysics evaluation during polar night. But one also can be interested in comparing between the two grid spacing, so the CAPS versus the experimental 1 kilometer system that would be running for real time, and so that would be interesting. For the cloud and microphysics, that's the part where I'm interested in. So first, we could take a look at the optically thin ice clouds, which can be two kinds, so small sizes or large sizes, and that depend also on the different concentration of particles in the clouds. And of course, these property of clouds depends on the mass and the number as well. So the size, mass, and number are related. So that will be something to be discussed if we want to output the three of them, or just the size, or and so on. We could also study the boundary layer cloud formation, the aerosol transport, and some microphysical processes, as Alexi mentioned. So I get a message here that it says that my connection is lost. I don't know if anyone can just write quickly in the chat to say, no, you're not lost. Or, oh, awesome. Okay, I'll continue then. So, and on the right, it's the time evolution of the number of aerosol. Actually, that was, this is preliminary results from the P3 microphysics using pronestic aerosols. So I'm not sure if the animation yeah, it's happening, but really slow. But we can see that it's changing a lot in time and space during this only 5 days in July. So I don't have an animation for January, but I will eventually soon. So that would be also something I will be interested into looking at. So next slide, please. I think the important part of my talk is this one, and then that's what I wanted to turn out more as a conversation than a presentation. And this will be the guidance for the flight planning. So if anyone wants to comment on all of this, you're welcome to contact me at the end, or we could discuss it live just after the talk. So the first thing to do is to make the outputs available on site, and I see two options for that. First one is to access directly the output on the server, on the ECCC server, but that will require a really good internet connection. Or the other option is to produce real-time PNG as the simulation is going on, and just upload the PNGs on a web page. That's also require an internet connection, but not as good as for accessing the server directly. And then, of course, there's all these file size questions that I don't have the answer yet. And then we should discuss also what outputs are needed. Of course, atmospheric state variables would be outputted. But for example, for the liquid and ice particles, do we need the water path? Do we need the content? Do we need the sizes of the particles, the mean size, the mass, the concentration, and so on? And what types of figures? Actually, 2D maps, cross-section, where, how many time series, where, how many, and so on. So, and finally, I think it will be good also to coordinate with the other teams, the other plans for modeling in that region during PONEX. So download apps if needed, forecast tools also, and coordinate with a forecaster that will be on site. It would be great if anyone knows who's gonna be on site directly. And so these are all actually questions that I don't have all the answers, but I will be really interested in knowing what you think of all this. So maybe after we can discuss a bit about that. So next slide, I think it's my conclusion slide. Yeah. So this is, I'm not gonna repeat the conclusions, but for the timeline, it's just that for the next few months, I really wanna answer those questions. And then from September to the deadline, I will set up the system and making sure it's running well, and elaborate tools if necessary to access the outputs over there. So thank you for listening, and yeah, please feel free to contact me if anyone has comment or questions about about high resolution modeling during PONEX.
Thanks very much, Melissa. Any questions here or online?
Does the model have aerosol composition information as well? I can see. So right now, GEM does not. It's something I've been working on to add pronostic aerosol number in P3 directly. So it's gonna pronounce two new equations. But right now it's not including that. But that's why in the slide before I said that we should contact the people that are, I don't know, maybe responsible in GEMMAC. I know that GEMMAC is using aerosol projection or other products that may exist that will have this product. This is relevant. Yeah, this is a good question. Right now, I don't think the system that I will be setting up will have this, but maybe if I have the time before then. Thanks.
Thanks, Melissa. The question for those in the room was, does the model have aerosol composition information as well?
Oh, I thought I said it. Sorry.
Thanks. Any other questions in the room? There is one follow-up question. What is the vertical resolution for the model?
Oh, this is a good question. But for now, it's gonna probably be the same one as the CAP system. So it's gonna be updated soon with a different vertical leveling, but it will have, I think, 82 vertical levels or something like that. So it's not gonna be coarse, but it may not be enough for the boundary layers clouds that are really important in that region. So this is something we could add as a scientific challenge to look at once we set up the system. Yeah.
Great. Thanks, Melissa. Any other questions? Okay. Thank you, Melissa. That was great.
Thank you.
And last but not least, Kaley will be talking about the ground-based observations during PONEX.
Okay, thank you very much. Hopefully I will be hearable online, and my apologies to those online if it turns out not to be that. So hopefully I can fill in some gaps on a few things that we've been talking about around PONEX in terms of the ground-based observations. So I'm here on behalf of the team of us who've been working on this. So Kim Strong and I at U of T, as well as Julie Theriault and Zen Mariani. So really, the place I wanted to start was really, this is a key part of how the University Consortium of HAWC is going to participate into PONEX. And so really we have a number of goals for our engagement. We have significant expertise in the academic community, which we think will be greatly beneficial in working with the ECCC and NRC teams. So in terms of field deployment, campaign management, measurements and instrumentation, training and experiential education, which we all bring to the table. And this is not the only suborbital campaign that will happen for HAWC. So this is our first one. And so it's really important to get out there and get as many of our community involved as possible so that we really can figure out what we need during the mission time period. Because if we decide that after lunch, that's too late. We won't have the time to acquire what we need, figure out when we needed that new instrumentation, what infrastructure are we missing. And also another place that the academic community comes in is in that training of the next generation. We will need people to work on HAWC long after I am retired. And so making sure that the HQP, those highly qualified personnel, if you don't know what that term is, you probably are one. It's you guys who are at the earlier stages in your career, but we also need you at all stages of your early career to come and be part of this. So learning about field deployment, data collection, doing your own analysis, working collaboratively. You heard from Melissa the need to work collaboratively on what things we need for this campaign. So being part of that conversation and then writing up your results and getting that full experience. So that's sort of the place I'm coming from and representing. But really, it's coming back to why ground-based measurements. I hope all the talks, such as Jipeng's that we just heard, have motivated the ones from WAFRS, why ground-based measurements are really important. So we get that local comparison data set for our flight instruments, giving us a different perspective from the instruments on the ground, from the ones on the aircraft, and really providing an extension of our calibration and validation data set. We've heard about the 2 prototype HAWC instruments that are going to be on board. We're also going to be doing work for EarthCARE validation. And ground-based measurements can be deployed for a longer time period than the aircraft. So we're able to provide a wider context, not only during the flight campaign, but also our goal is to start in the fall and end in the spring, so that we have that additional contextual information, making sure we have from the ground the MET variables we need, water vapor, clouds, aerosols, radiation, and other measurements. And really, not only in enabling the CalVal part of the PONEX mission, but to enable the scientific side. So it's really, really part of that integrated whole. So the measurements we have planned, you've heard a little bit about some of this, but I'll try and tie it all together. So we're going to build from the surface meteorological instrumentation that's at the Inuvik airport. So there's an ECCC weather station operating at the Mike Zubko airport. So our primary site's going to be located there, fenced in, with protection from wildlife and on all those other things. And you heard about the Trail Valley Creek Research Station. That's going to provide our secondary ground-based site. There's a few more fun challenges with it. So you'll notice that I'm saying proposed, under consideration. We really want to do it. It's just figuring out how to do it at this point. And you heard from Julie that it's about 50 kilometers north of Inuvik. There's also an upper air station that makes regular radio SON measurements. And so we will have additional SONs flown during the PONEX flight campaign to time with particular measurements we need or to further some campaign goals. So this is just to give you a flavor of where the sites are. On the right-hand side, the blue circle shows you where Inuvik is in the lower part, and the Trail Valley Creek site is at the pink circle. On the left-hand side, you'll see that the upper air station is separated from the airport itself. The main place we're going to be based in is the hangar there, and you can see that in the left-hand picture. So this is going to be our main location for the campaign, and I believe the term I use is heatable. Sorry, that's a team joke. Our ground-based instrumentation setup is going to look like this lovely one shown here, which I stole from some slides. I think they're from Zen rather than from Natalia, from Wintermix. So that's the kind of thing we're going to be putting up. So to give you a sense of what those things are inside the fence, I'm going to try and do them by theme. So on the left-hand side, we have a focus on meteorological surface conditions, precipitation, and classification of hydrometeors. So we have a pluvio rain gauge, the laser distrometer, a forward scatter sensor, which is going to give us some rain rates and other things, and then a weather station. Now, I've used some color coding, things that are in black, not in a different color. Those are going to be are planned for both sites. And it's the forward scatter sensors is, in this case, only going to be at the Inuvik airport. Looking more at cloud composition and aerosols, as well as radar reflectivities, we have the microrain radar and the Doppler LiDAR, which will give us a whole other set of things to look at, give us some comparisons with the Convenor radar, which we heard about earlier, and also with the ALI. This suite of water vapor and temperature measurements is solely going to be located at the Inuvik airport with the dial LiDAR measurements for water vapor. We have a profiling radiometer from Radiometrics, and my fingers are crossed that we can have the ARRI from McGill. So this is really going to focus on what we can do individually with the instruments, comparing between them, because we do have overlapping between the the water vapor LiDAR, as well as measurements of water vapor from the radiometer. What can we do in bringing those data sets together and then comparing between them with the Convenor measurements, and really sort of pushing on what we can do there. And also, I would be neglectful if I didn't mention that it's important to look not only at trace gases and temperature, but also at radiances, particularly for the FEAR2. Now, Trail Valley site, you'll see that we have very similar focus on the left-hand side for meteorological surface conditions, precipitation, and hydrometeors. And in this case, we have the addition of the Met Tower, which I believe answers K1's question from earlier. We don't exactly know what's on it. And so that's an important conversation for what we're leading into, but there is one there, which is good. And then on the right-hand side, having the micro rain radar and the Doppler LiDAR. So we have a nice complementary suite of measurements in those two locations, with some that are consistent and some that are value added in each place. So in terms of our team from the universities, our roles, we are going to bring our army of HQP to get field experience, but also to get involved in taking responsibility for the ground-based sensors. So being on site, maintaining them during the campaign, doing the data collection and analysis. Also, we need some of our HQP to support aircraft deployment. I believe Natalia has a series of tests that she puts you through as to whether or not you'll be able to stay on the aircraft. She's kind, really. But anyone who's a student or a postdoc in the audience who may be interested, please come talk to us. I can strong arm your supervisor into getting involved. And then the second part is the analysis of data. When you're on site, making sure that you're able to report on, when we have daily briefings, what came from the ground-based site, how you're going to be responsible for what your instrument saw. So it's really being part of this campaign and understanding the stresses and the joys of being part of a field campaign. And also making sure that you're part of the quality control. This is an important consideration. Having an instrument is great, but making sure that you're producing a data set that when we make it public, you have full confidence in and is well quality controlled and archived is really important. And these are excellent projects for a chapter in your thesis. So if you're interested, come talk to me. So in summary, we've got 2 ground-based sites in development for the PONEX campaign. We have planned at the Inuvik Airport, and we have a proposed at Trail Valley Creek Station. Basically, we're aiming to extend and augment the data set coming from the Convenor to really fill out the science and the CalVal that we want to do. We'll use this as preparation for future HAWC suborbital campaigns so that we are ready to do the most that we can during our early launch and scientific operations phase. And then we also have wonderful training opportunities for our HQP to be involved all the way from the fieldwork side through the publications. So development is continuing between Environment Canada and the university team, as well as in collaboration with NRC. We are putting together our proposal for the announcement of opportunity that came out conveniently on the 24th of May long weekend to support the field campaign activities and the analysis. So thank you very much for your attention. I'll take any questions.
Hi, thanks for that. So I'm Philip Marsh. I'm from Wilfrid Laurier University. And
Hi, Phil. Nice to meet you.
Nice to meet you. Director of the Trail Valley site. So I don't have a question, but I can answer your questions if you want.
I'm pretty sure we're going to have
do that now or later. I don't know what's.
I think we should have a conversation in the discussion phase.
Okay.
Yep.
So just really quickly.
Yep,
so
please.
we have 2 eddy covariance two towers, a 10 meter, 20 meter with eddy covariance measure instruments on it. So full water fluxes, sensible heat, carbon, CO2, methane fluxes. So we have those full sites. And we have another eddy covariance system right by the upper air station in Inuvik as well. So,
Year-round operations?
theoretically, yeah.
Okay.
Yeah, I mean, we have a really good power system at the Trail Valley campsite that provides power to both of the eddy covariance systems, heats the sensors. So they work some of the time. It's impossible to keep them melted. If we have somebody on site, though, like during January, you could keep them going all winter for sure, all January for sure. Yeah.
So that's something that we do need to think about in terms of the AO. What do we want? Where are we going to put our resources?
Yeah.
Thank you for that. So I didn't misrepresent the tower, did I?
You did not.
Great.
No.
K1, did you get your question answered? Perfect. Thank you so much.
Okay, thanks.
Thanks. Any other? Oh, yeah, go ahead.
Just I wanted to add, I had a discussion with Norm, and he is interested to send a sun photometer, moon photometer. Still, it's not confirmed, but I think it would be a good add.
Okay, so is that via him or is that via EHAB?
I think he said he will talk with EHAB.
Okay. Yeah, we actually, Zen and I need to know what that is. So he needs to loop us into the discussion, please. I understand that, but rapidly making plans and then finding out that it's not included in anything we have makes things more challenging.
Thanks. Any other questions right now?
Okay, shall we declare the talk part finished? And how many people do we have online? How do we want to proceed with the discussions?
11 online. So
Okay.
we need to stay mic'd up.
I think we do need to stay mic'd up. How do you want to do this? Actually, can someone ask those online, can you hear us? And can we get a roll call of who's on? Because no one can tell us. We know X number of people are online, we just don't know who they are. And it's kind of nice to know. So I'm guessing Melissa's there, Shipeng? Sorry? No, that's not what the question was.
There's Melissa, Alexi, Jipeng, and then the rest I don't.
Okay. Yep. Okay.
Leon's online.
Great.
And they can hear us okay.
Okay, great. Thank you very much. So would we like to talk about hearing about people's interest in particular components of PONEX? So we've heard from those who've talked. I've heard from a few people. I've had some questions. Anything we haven't covered, any components that people would like to bring out? Anyone online?
Hello. So the deadline for the CAC application is soon. How did you envision?
Yeah. So my envisioning is that I have made a call out to consortium members on HAWC for who is interested to participate. I have a collection of those. I need to reach out to a few more people who I know were interested but either didn't reply or sent me an auto reply because they were on vacation. We need to understand the complexities of the way the AO is written as to how we need to make the application. At the moment, the vision we were hoping for was that we could have a logistics grant that covered preparation of instruments, deployment of people, travel, all of that, which would be run through one university. That would be U of T, headed by me, led with Kim, and then, you know, with you, Julie, and a few others as co-Is, and then lots of collaborators participating. And that would cover our costs for getting people into the field, getting the data collected, and then we have to understand whether we can put the data analysis into that grant or whether then we have to take and divide up the remaining money. And because of the very interesting CSA rules, there may need to be a bunch of individual, they don't understand how a field campaign works, that it's one big team, so that we may have to figure out individual grants for people to support a student, which seems very silly, but. So we have a notice of intent that is due 2 weeks from Friday. And so we need to assemble people. My hope is that next Monday morning Eastern time, we will have a telecon and we will discuss plans. So for those who are in the room and online and interested, please send me an email to say your availability from say 9 a.m. to 11 a.m. or 8 a.m. till 11 a.m. on Monday, I don't know, let's pick a date. It's the 2nd, I think. Yeah, you will get an email about it, but this is just to start those coming in. Okay.
My question is that for this call, I guess for the participation for academic, if we want to send instruments to Inuvik, we will only have the answer in October, but it's too late to send instruments in October. So how would that
So
work?
this is a more of an offline conversation, because we
Okay.
understand that we have every single instrument someone has said I'd like to bring comes with a completely different timeline that doesn't fit into the put it in Zen's container before the end of June.
Yeah, your container.
Yeah, but that's the end of June. But we do have containers going at different times. We also need to understand for the contributed instruments sensitivity to cold, because these will not be heated. So if your instrument needs to be in warm storage all the way through transport, that's one thing we absolutely need to know, because it doesn't necessarily go in one of the containers that might be sitting outside or might be in the hangar when it's -30.
So we can send you something, sit there, and if it doesn't work, you just sit there and come back. I'm not sure, like, the logistics.
Yeah, so the timing is tight, you're right. So essentially there's three options. The first is the first container that Environment Canada has is leaving Downsview in July. There is some space available, so it can come in July, it goes in September. I'm going up with a team, we're deploying the site in September, primarily because it's not frozen yet. So it's a little bit nicer to work out in September. The site's running from there. Option 2 is there's 2 containers in Ottawa that will go up in December. Yeah, so they're going up, I think they leave in November, arrive in December? Late October, excuse me. And so with that option, that's the second wave. We'll know about the funding. The challenge is they're not heated. They're being dropped off in the hangar. They're being left there, and the hangar's not heated in December. So we're talking -40, plan for the worst kind of thing.
Yeah.
So there's a challenge there.
Yeah. So the third option on that is if we can identify a timing and a cost for shipping that gets it there, we can include that in the AO.
Yeah.
So that would be what I figure is under the logistics. So it's deployment of the instrumentation on the academic side. We know our shipping costs, we know our people costs, that all fits into logistics. It may have to run through the University of Toronto, but I think we can all work nicely together and make that work. But it's really, what's the best way to get your instrument there? Because it's fine if it can go in the NRC container. I'd just be worried about if anything was well aligned or had any liquid in it.
Yeah. The comment was for like Trail Valley. It should go up for the September shipment.
Yeah. So Trail Valley, we may have to take some business risk or figure out how to do it, which I think is another reason why I think there needs to be a couple of different levels of conversation within the academic group. You know, those of us who really know how we want to do things and have logistics experience, and we'll just make a plan and we'll figure out how to do it.
Right. And on the flip end of it, the plan is to ship everything back by the same containers at the end of the campaign. So everything's coming back the same way it went out, basically.
Yeah. So if we're counting,
or it can stay at Trail Valley if you want to keep it at Trail Valley.
Yeah.
Right?
So if it's a deployment that if we can continue it through and then it helps for next summer, that's brilliant. But if something comes up, yeah. We need, yeah.
Right.
Yeah. 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 I think it's, at this point, it's a matter of let's make a plan and then we'll all sit there and poke at it and see if we can break it. And if it's not too bad, then we'll say, okay, that's what we do. Okay. Anything online?
Oh, yes.
So apart from Ali and the FUR 2, are there any other of the instruments on the mission that have space-based or have planned to have a spaceborne instrument?
So I think so SHOW cannot make measurements from the altitude of the Convair. So from a HAWC standpoint, the only two instruments we can have from HAWC AOS are Ali and FEAR 2 as the prototype of TICFIRE. So
I meant like the other instruments that are going to be on the PONEX. Do any of them have a spaceborne counterpart?
do you want to handle that or do you want to handle it?
In terms of the EarthCARE satellite, for instance, there's a lot of complementary observations that'll be on board the Convair. So that's what was in Jipeng's talk. He was showing how we can compare to the EarthCARE observations using the EarthCARE LiDAR and the EarthCARE radar. Convair will have the same suite of instruments. And Natalia, did you want to perhaps add to that?
Yeah, so the radars on board will be X-band, W-band, and Ka band. W-band is the same frequency as the CPR on EarthCARE. The onboard LiDAR is also the same wavelengths as the Athlete on board of EarthCARE. So that is in terms of the remote sensors. The HISRAM sensors that I mentioned in my talk are somewhat similar to some of the orbiting existing microwave sounders, but they're also a prototype for potential future missions, but nothing in concrete plan yet.
I think, Zara, maybe a way to think about it is what we did for ASOSIRIS campaigns in Eureka, that we had a couple that were ground-based versions or airborne versions of the satellite instruments, but everything else was built on a suite of complementarity. And particularly based on what we've seen here, the flight heritage we have with the Convair instruments, and even with and then having these new ones like the HISRAMs coming in, I think gives us such a strength for complementary measurements and for validation. Yeah, this is going to be awesome. Sorry.
Good question, though. Thanks.
There's a question.
Oh, yep.
So there is a question online from Melissa asking, anyone knows about how will be the internet connection on site, or is it too soon? Well, we had a couple of people there in March. They said that internet exists and it was not too bad. So there's hope in that regard.
Did you want to add to? Yeah, I figured.
Is it too bad? Not too bad for two people.
So,
and Phil. Go.
So on the internet thing. So at Trail Valley, we have good satellite internet. That's pretty robust.
Yeah.
Most of my students say it's better than they have at home. So,
Yeah. So
which might not say much, but
which service do you pay?
we use Starlink.
Okay. Yeah.
It's awesome, I must admit.
Yeah.
Like we can have Zoom calls, Teams calls to groups at Trail Valley, no problem. And we have Wi-Fi from there over most of our instrument sites as well.
Yeah. Yeah. At Pearl and Eureka, we have a Galaxy OneWeb and a Starlink because we have backups of each one,
Yeah.
which means that for once we can have Zoom calls.
Yes, yeah.
Which is kind of bizarre.
It is very bizarre, but it works.
Yeah.
It's nice and nice. Yeah, it's not great in town. It's better at Trail Valley than hotels in town often. Yeah. For complex reasons I don't understand.
Any other questions, comments, suggestions?
Rachel.
So, for example, I have not been part of this conversation at all, but I'm curious if there are instruments or measurements that you feel are lacking right now that you're making a call to the community to provide. I mean, I know Environment Canada has all the things and don't really need anything else that we have.
Go ahead.
What's your dream?
I'm going to respond on behalf of Alexei here. I think we're looking for backup instruments for some of the gas measurements. There were also some risks on the aerosol side of things because one of the instruments that we're expecting to have on board comes from our US partners, and their situation is a little bit uncertain at the moment.
To put it lightly.
Yeah, the trace gas is a big one. If Alexei's online, he might chime in, but
I think it's figuring out where the holes are with things that we have space for, if it's gonna fly, and we can easily implement. That will cause several people's blood pressure to go back up.
Yes. So from a very practical point of view, so for our Trail Valley site and related areas, we have a NWT science license. So in terms of any activities we do for PONEX at Trail Valley, that'll be covered under our, so I have a 5-year science license with the NWT. That January is probably in the middle, but we do other things in the winter. So we will have that process. That's all in. Yeah, we have that all sorted out.
And I think it might have been covered under the license that we've submitted already. So doubly covered is better than zero, which is brilliant. Thank you. But that for those people who don't work in the territories, it's very important to understand licensing.
yeah, so we obtained the licensing and approval from Northwest Territories as well as from NAV Canada to operate our instruments next to the airport because, of course, you tell them you're going to operate a LiDAR and they freak out, obviously. So, but no, that part's luckily good.
Did we get another one?
Alexei
yeah.
might want to say something.
Can we unmute Alexei, please? The problem is that, yeah, he needs
Alexei, give us 1 minute. We're just going to try to unmute you.
Can you? No, he needs to be invited in as a speaker because he didn't talk in this session. We don't think he has the link, but Natalia is going to try and work some magic. I mean, compared to some of the problems we've had with the technology, we're doing really well.
I was just going to ask one other sort of practical thing. Have you been involved or in conversations with any of the Inuvik allied groups in Inuvik? Because we have links with some of them. So through Laurier, we have a memorandum of understanding with a couple of groups. So we could help, because the communities love to know about what's happening, what the planes are flying, what we're doing, and probably something dealing with improved weather forecasting will catch a lot of people's attention, I would guess.
So Zen, do you want to start that? And then I can.
Yeah, I mean, short answer is yes. And, but definitely, I think those contacts would help strengthen that connection. And there was a comment in the session this morning along the same lines and building some additional connections while we're there. But we've reached out, for instance, to there's the Hunter and Trapper Society and a few groups who are interested just in general. And of course, the connection is the weather forecast. That's the big one, right?
Yeah.
Sorry, Kaley,
So-
go ahead.
Oh, no, I was going to say that the way I view it is that part of these continuing visits as we lead up to start to, or can be building those relationships. And Leonid and I have been talking about what else we can do sort of on a more outreach in the schools. So we were talking with Catherine, who's actually a geologist, but does some work in Inuvik about how we can pair together between our project and hers to further offer educational experiences, but more than just a talk to your classroom, but more collaborative research ways of working together. So I think that would be great to try and diversify all those different ways we're talking to the community, communicating with the community about what we're doing, why we're doing it, how you can come out, if we have an open day or something, to come out and, I don't think we're allowed to let them touch the conver, but at least we can let them see it. Fingerprints all over the diamond window?
I think that might be it. I know Alexi did have a comment.
It's not provided, unfortunately, we cannot mute him because he wasn't the speaker.
And we haven't gotten anything in the chat. So Alexi, if the fingers feel like talking, please do so. Well, how about we call it an early break? And for those who are likely to be involved in the AO, I suggest how about we find a table and have a seat.
Yep, and I'd just like to thank everyone for coming. This is very exciting, and obviously, oh, there's another question. There we go.
Brilliant. Is anyone planning to provide forecasts for flight guidance? I'm pretty sure the answer is yes. Who is it?
Yes. So there are, we will secure a 24/7 dedicated meteorologist, probably out of the Edmonton area, to support the campaign for flight operations. So that's the idea. Whether they're going to be on site or Melissa, if you want to fly to Inuvik and stay there for the campaign, that remains TBD, but certainly we'll need that guidance, and Environment Canada will get a meteorologist for that.
I'll just add that Jean-Pierre Blanchet was also volunteering to run the forecasting similar to how he did this winter for the wafers campaign.
Yeah. So there's a couple different options in that regard. Perfect. Well, thanks everyone. This was great. And for those who are interested in talking about more about the AO and the technical details, please feel free to stay and we'll sit around a table and chat. And thank you everyone online.